Hello everyone, in this video we are going to discuss examples of the chapter real numbers. Before going to start our session, please subscribe to my channel and don't forget to press the bell icon to get all the notifications. So example 1, show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1 where q is some integer. Let a be any positive integer and b equals to. So this b will be given in the question itself but a little indirectly. 2q plus 1. So that number 2 is there, right? That is b value. So b equals to 2. Now let us write our Euclid's division formula. What is that Euclid's division formula? A equals to bq plus r. So before going to write that one, let us write all the possible reminders. If b equals to 2, then the possible reminders. What will be the possible reminders here? Always the reminders will start from 0. Then till where we need to take those 0, 1, 2, 3, 4 till 100 till 1000 till 5000 till 1 lakh, otherwise 1 crore. So always the reminder will be less than the divisor. So in this case the divisor is 2, that is nothing but b value. So the divisor is 2, then the remainder will be less than 2 only. So less than 2 is nothing but 1. So if the b value is 2, then the possible reminders are 0 and 1. Now let us write our Euclid's division formula. A equals to bq plus r. A as it is, b value 2 into q plus. In the remainder we have two possibilities, right? One is 0 and one is 1. So first let me write 0. So what will get then? A equals to 2q plus 0, 2q. Next a equals to 2q plus r. R remainder, now second remainder I am taking, that is 1. So a equals to 2q plus 1. Now if we observe these two clearly, here a equals to 2q, no remainder at all. So this will become even form. Then a equals to 2q plus 1. 1 is odd number. So this is odd form. So now we can conclude one thing, that is any positive odd integer is of the form 2q plus 1 and any positive even integer is of the form 2q. Next, show that every positive odd integer is of the form 4q plus 1 or 4q plus 3 where q is some integer. Let a be any positive integer and b equals to. So b will be given in the question itself. 4q plus 1, 4q plus 3. So the b value will be 4. If the b value is 4, then what are the possible reminders? 0, 1, 2, 3. Always the remainder will start from 0 and the remainder always will be less than the divisor. So in this case the divisor is 4, so the remainder will stop till 3 only. Now let us substitute this in our formula. A equals to bq plus r. A equals to b value 4, 4q plus reminders. We have 4 possibilities, right? So let us go with 1 remainder. So first I am going with the 0 remainder. A equals to 4q plus 0. Then a equals to 4q plus 0, 4q. Then the second remainder, a equals to 4q plus 1. Next remainder, a equals to 4q plus 2. Then last remainder, a equals to 4q plus 3. Now let us check one by one here. Here remainder only not there, so it means this is even form. Then here plus 1 is there, so this is odd form. Then here plus 2 is there, so this is even form. Then here plus 3 is there, so odd form. So we can say that every positive odd integer is of the form 4q or 4q plus 1. Next, check whether 4 power n ends with the digit 0. So in this question, one sentence we need to write, that is must and should. To be end with the digit 0, it should have 2 and 5 as factors. 4 power n equals to, here 4 can be written as 2 square whole power n, that is equals to, for any number if 2 powers are there with bracket means we can multiply those 2 powers. So 2 power 2 into n, 2n. So now according to this lines, what these lines are saying, to be end with the digit 0, it should have 2 and 5 as the factors. So any number, if you do prime factorization, in that 2 as well as 5, I repeat, 2 and 5 both are there means then only it will end with the digit 0. So now if we observe this clearly, here number 2 is there but number 5 is not a factor. So number 5 is not a factor, then definitely this 4 power n cannot end with the digit 0. So that only we will write it as number 5 is not there, right? So as 5 is not a factor, 4 power n cannot end with digit 0. Next, find the HCF and LCM of 12, 18 by the prime factorization method. So let us do prime factorization for the number 12 first. 12 will come in 2 table. So 2 6 are, 6 will come in 2 table, 2 3 are, 3 will come in 3 table, 3 1s are. Next, for 18, 2 9s are 18, 3 3s are 9. So 12 equals to 2 into 2 into 3. Then 18 equals to 2 into 3 into 3. Now we need to write HCF, then I will go with the LCM. So HCF, to write the HCF, first some number should be common in both. Here 2 is there, here 2 is there, here 3 is there, here 3 is there, but that's it. Except these, nothing else is common, right? So 2 is common, write that 2 here, into 3 is common, write that 3 here. 2 into 3, 6. HCF of 12 and 18 is 6. Then coming to the LCM part. First write what are common, that is 2 into 3 into. Now whatever the extra numbers are remaining, those all we need to write here. Here into 2 is extra, so write that 2 into, here 3 is extra, write that 3. So if you multiply all these, 2 3s are 6, 6 2s are 12, 12 3s are 36. So LCM of 12 and 18 is 36. Next question. Check whether the following are terminating or non-terminating repeating type of decimal. How we will decide whether a given rational number has terminating decimal or non-terminating repeating type of decimal? If the denominator is in the form of 2 power n into 5 power m. I repeat, if the denominator is in the form of 2 power n into 5 power m, then the rational number has terminating decimal, otherwise non-terminating repeating type of decimal. So what exactly this 2 power n into 5 power m means? In the denominator, only number 2 should be there, otherwise only number 5 should be there, otherwise both 2 and 5 should be there. Then only it will be having a terminating decimal. Except these numbers, if any other number is there, then automatically it will be having non-terminating repeating type of decimal. Let us check this question now. 16 divided by 125. So 125 is nothing but 5 into 5 into 5. Here, if we observe the denominator, in the denominator except 5, nothing nothing else is there. So it will be having terminating decimal. Either 2 or 5 or both 2 and 5. Then only terminating. Let us check one more. 25 divided by 32. So numerator 25 as it is, by 32 can be written as 32 if you do prime factorization. Of course, if you know directly, you can write that is 2 power 5. 2 16s, 2 8s, 2 4s, 2 2s. So 1 2 3 4 5. 2 power 5. Now if we observe, the base of the denominator is 2. So the denominator is in the form of 2 power n into 5 power m. So it has terminating decimal because the denominator base is only 2. Next, 100 divided by 81. For 81, if you do prime factorization, 81 will come in 3 table. 3 27s, 3 9s, 3 3s. So 100 divided by 81 can be written as 3 power 4. As I said already, the denominator should have only number 2 or number 5 or both 2 and 5. But here, except those numbers, some other number 3 is there. So that is the reason this denominator is not in the form of 2 power n into 5 power m. So it will be having non-terminating repeating type of decimal. Next, 41 divided by 75. Let us do the prime factorization for the denominator 75. 75 last digit is 5, so it will come in 5 table. 5 ones are 5, 2 remains, 5 5s are 25. Again 15 will come in 3 table, sorry 5 table. 5 3s are 15. So 41 divided by 5 is there 2 times, 5 square, into 3 is there 1 time, so 3. Now, as I said, in the denominator, we should have only 2 or only 5 or both 2 and 5. So, no other number. But here, some other number 3 is there. So, that is the reason this denominator is not. This sentence is must and should every time. Denominator is not in the form of 2 power n into 5 power m. So, it has non-terminating repeating decimal. Next, write the decimal without actual division. So, when it is possible to write the decimal, that too without doing the actual division. If the denominator has number 10 or 100 or 1000 or 10,000, 1 lakh, like this 0 numbers are there in the denominator, then it will be very easy to write the decimal. So let us do that kind of problems now. 35 by 50 is there. As I said, in the denominator, number 10 or 100 or 1000 or 10,000 or 1 lakh, like that, these kind of numbers. Now observe the denominator here. Here the denominator is 50. In 50 table 10 won't come, so 10 is not necessary for us. Next, 50 table 100 will come. So in 50 table where 100 will come? 2s. That is the reason you multiply and divide with 2. 35 into 2, 70. By 50 into 2, 100. Here 0, here 0, both will get cancelled. Then remains with 7 divided by 10. 7 divided by 10, 0.7. Next, 21 divided by 25. In the denominator, we want 10 or 100 or 1000 and so on. In 25 table, 10 won't come. 25 table, 100 it will come. Where it will come then? 4s. So multiply and divide with 4. 21 into 4, 84. By 25 into 4, 100. 84 divided by 100, 0.84. 7 divided by 8. So the denominator should have 10, 100, 1000 and so on. Now, if we look at the denominator clearly, first number is 10. In 8 table, 10 won't come anyway. In 8 table, 10 won't come. Next, in 8 table 100 will come then. Of course 100 also won't come. Next, in 8 table 1000 will come. Yes, in 8 table 1000 will come. I forgot to cut this. In 8 table 10 won't come. In 8 table 100 won't come. In 8 table 1000 will come. Then where this 1000 will come? In 125 table. So multiply and divide with 125. 7 into 125, it is 875, divided by 8 into 125, 1000. 875 divided by 1000, 0.875. Next, show that root 2 is irrational number. So we will prove this by using a method called contrary method, or else proof by contradiction. Okay, let us start doing this. For these kind of questions, these first sentences are compulsory. On the contrary, let us assume root 2 is rational. So root 2 equals to a by b. And here conditions we need to write: must and should. A comma b belongs to integers. B not equals to 0. A comma b are co-primes. Now for this question, we need to do squaring on both the sides. So root 2 equals to a by b is there. Root 2 whole square equals to a by b whole square. Here square both will get cancelled. Then we remains with 2 equals to a by b whole square. This square is applicable for the numerator as well as for denominator. Then we remains with 2 equals to a square divided by b square. Now take b square to the left side. So we remains with 2b square equals to a square. Keep this equation aside. Now this 2 also you take to the right side. Then we will get b square equals to a square by 2. So what exactly this a square by 2 means? A square by 2 means 2 divides a square. 2 divides a square. If 2 divides a square, then 2 divides a also. 2 divides a, that can be written as a by 2. So if 2 divides a, then definitely we will get some answer. That answer I am making equal to some constant c. Now take this 2 to the right side. So we get a equals to 2c. Now observe the previous equation and this equation. Sorry. In the previous equation, we have 2b square equals to a square, and here a equals to 2c. So 2b square equals to a square. 2b square equals to a square. Here in the place of a, this I am going to substitute. 2b square equals to a is nothing but 2c. So 2c whole square. 2b square equals to 2c whole square, 4c square. 2 1s are 2 2s are. B square equals to 2c square. Take 2 to the left side. B square by 2 equals to c square. What exactly this b square by 2 means? B square by 2 means 2 divides b square. If 2 divides b square, then 2 divides b also. From the previous sentence, 2 divides a and here 2 divides b. We can do one conclusion, that is 2 divides a and b. A and b. So 2 divides a and b means for the a and b, the common factor is 2. But it contradicts the fact that a comma b are co-primes. Co-primes means what? A comma b will be having only number 1 as the common factor. But here we got 2 is also one of the common factors. Then it contradicts the fact that a comma b are co-primes. So root 2 is irrational. Next, show that 5 minus root 3 is an irrational number. First sentence is as usual. On the contrary, let us assume 5 minus root 3 is rational. So 5 minus root 3 equals to a by b. Conditions: a comma b belongs to integers, b not equals to 0, a comma b are co-primes. Okay, now the same equation I am writing down again. 5 minus root 3 equals to a by b. 5 minus root 3 equals to a by b. Now what I am going to do is, I will take this minus root 3 to the right side and a by b to the left side. So 5 a by b will become minus a by b equals to minus root 3 will become plus root 3. Here left side we have 5, right? That 5 I am writing it as 5 by 1. So here left side, both the denominators are different. Let us do cross multiplication. 1 into b, b. 5 into b, 5b. Minus 1 into a. That is equals to root 3 as it is. Okay, now in the condition we took a comma b both belongs to integers, right? So from the integers, any number you substitute in the place of a and b, always this left side part we will get a rational number only, whereas this right side part is irrational number. So we need to write the statement as a comma b are integers, LHS is rational, but RHS is irrational. This contradiction has arisen due to our wrong assumption. Next, show that 3 root 2 is irrational. Simply 3 root 2, it's very easy. Nothing is there to worry about this. 3 root 2. This is asking to show that it is an irrational number. Okay. Now, first statements as usual. On the contrary, let us assume 3 root 2 is rational. So, 3 root 2 equals to a by b, where a comma b belongs to integers, b not equals to 0, and a comma b are co-primes. Now, I am taking this 3 to the right side. Root 2 equals to a divided by 3b. Now, already according to the condition, a comma b both are integers. So, whatever the integer you substitute in the place of a and b, always this right side part is a rational number only. Sorry, not RHS, rational it is. This is always a rational number only. But LHS, root 2 is irrational number. LHS is not at all equals to RHS. So, write that condition only here as a comma b are integers, RHS is rational, but LHS is irrational. This contradiction has arisen due to our wrong assumption. Next, show that root 2 plus root 3 is irrational. On the contrary, let us assume root 2 plus root 3 is a rational number. So, root 2 plus root 3 equals to a by b. Now, here root 2 plus root 3, both the numbers are having a square root. So, it is not possible to solve just normally. So, that is the reason we need to do squaring on both the sides for this. Squaring on both the sides. So, what we will get then? root 2 plus root 3 whole square equals to a by b whole square. Root 2 plus root 3 whole square, it is in the form of a plus b whole square. Then if we expand, root 2 whole square plus root 3 square plus 2 into root 2 into root 3 equals to a by b whole square, a square by b square. Square root square cancel. Then remains with 2 plus 3 plus 2 into root 2 into root 3 root 6 equals to a square by b square. 2 plus 3 5 plus 2 into root 6 2 root 6 equals to a square by b square. Take 5 to the right side. If you take 5 to another side, then it becomes minus 5. 2 root 6 equals to a square by b square minus 5. This normal 5, I am writing it as 5 by 1. Left side part I am writing as it is 2 root 6. That is equals to, here both the denominators are different, so I am going with the cross multiplication process. B square into 1 b square, a square into 1 a square minus b square into 5 5b square. Next, this 2 also I will take to the right side. Root 6 equals to a square minus 5b square divided by 2b square. Now same like the previous questions, we need to write the condition. As a comma b are integers, RHS is rational but LHS is irrational. This contradiction has arisen due to our wrong assumption. Expand log 343 divided by 125. So we have one formula in logarithms. Log a by b equals to log a minus log b. So in logarithms, if division is there, means we will write it as the subtraction. So log 343 by 125 can be written as log 343 minus log 125. So next, log 343 7 cube minus log 125 5 cube. Next, one more formula in the logarithms. Log a power m equals to m into log a. In the logarithm, if the power is there for the main number, it will come to the front as it is. So log a power m equals to m into log a. Then this power will come to the front, this power will come to the front. So finally we will get 3 log 7 minus 3 log 5. Now in this 3 log 7, 3 log 5, 3 is common. So I am taking that 3 common. Then we remains with 3 into log 7 minus log 5. Next, 2 log 3 plus 3 log 5 minus 5 log 2. We need to write this expanded logarithm as a single logarithm. In the previous question, they gave single logarithm and we did expansion. Now in this, already it is expanded. We need to make it a single logarithm. So the formula which we are going to use for this question is log a power m equals to m into log a. Right? If a power is there for the main number, then it will come to the front as it is. Now, the same formula in reverse. If front side of the logarithm a number is there, means it will go as the power. So here before log 2 is there, this 2 will go as the power for 3, and this 3 will go as the power for log 5, and this 5 will go as the power for 2. Okay, so what we will get then? Log 3 power 2 plus log 5 power 3 minus log 2 power 5. Log 3 square, 3 3s are 9, plus log 5 cube, 5 into 5 into 5, 125, minus log 2 power 5, 2 into 2 into 2 into 2 into 2. So 32. Next, the formula which we are going to use here is log A plus log b equals to log AB. In the logarithm, if plus is there means we will multiply. So log 9 plus log 125 can be written as log 9 into 125 minus log 32 as it is. So here log 9 into 125, 1125 minus log 32. Here one more formula which we will use is log A minus log B equals to log A by B. In logarithm, if minus is there means we will write that as division. So log 1125 minus log 32 can be written as log 1125 divided by 32. Next, solve 3 power x equals to 5 power x minus 2, and we need to find out the x value from this by using the logarithms. So first, for the given question, apply log on both the sides. So we get log 3 power x equals to log 5 power x minus 2. Here the power is x minus 2. In x minus 2, two terms are there. So not to have any confusion in the next steps, I am keeping bracket for that. Here power is there for the main number, it will come to the front. Here power is there for the main number, so it will come to the front. Then what we will get here, x log 3 equals to x minus 2 log 5. This left side part I am writing as it is, x log 3 equals to x into log 5, x log 5 minus symbol as it is, 2 into log 5, 2 log 5. Now what I will do is, this minus 2 log 5 I will take to the left side, x log 3 I will take to the right side. So minus 2 log 5 will become plus 2 log 5 equals to x log 5 as it is. X log 3 I am taking to another side, right? So it will become then minus x log 3. This left side part, this 2 I will take as the power. So log 5 square equals to x log 5 minus x log 3. We can take out x common, then we remains with log 5 minus log 3. Log 5 square 25 equals to x into log 5 minus log 3. It is in the form of log a minus log b. So log a minus log b is equals to log a by b. That is, if subtraction is there means we will write it as a division. So the same way, log 5 minus log 3 can be written as log 5 by 3. Now we need to find out the x value. So take this log 5 by 3 to the left side. Here it is multiplication. If you take another side, it becomes division. Then x value is log 25 divided by log 5 by 3. Here we should not cancel log. Just keep that in mind. Next, if 2 log 5 plus half log 9 minus log 3 equals to log x, then find out the x value. Here, before the log number is there, then it will go as the power. Before the log number is there, then it will go as the power. So we get the first step as log 5 power 2 plus log 9 power half minus log 3, which is equals to log x. Log 5 square, 5 as a 25 plus log. What is the meaning of 9 power 1 by 2? Power 1 by 2 means root. So root 9 minus log 3. That is equals to log x. Log 25 plus log root 9 3 minus log 3 equals to log x. This is plus log 3, this is minus log 3. Both will get cancelled. Then remains with log 25 equals to log x. So by comparison, left side log is there, right side log is there. So remove those logs. Then we get x value as 25. Here you should not cancel log like this. Don't do that simple mistake. Okay. So by comparison, x equals to 25.